Alrighty, hopefully everyone's in the right place. This is a Windows 10 IoT core session. Is that what everyone's expecting after lunch?
Yes.
Good. I've got quite a few demos. Oh, there's one chap over here who thinks maybe not. And so I've got a little intro. So my name's Dave Glover. I'm a developer evangelist, Microsoft based in Sydney. Been around for a while, and you probably tend to see me on the gadget end of stuff that Microsoft does. So I've done a lot around phone, around desktop, actually around web for that matter. Pretty much a whole stack of a lot of things. But over the last year or so, have done quite a lot around IoT and Internet of Things. How many people were here for, or not here, but were at the last tech ed we ran in Sydney and Melbourne? So how many of those went to the Maker Den? So a few. Oh, okay, great. So people rocked up to that. I've been doing it for about a year. The previous generation, we were kind of doing a lot around NetDuinos, which are firmware-based devices, which ran .NET. This session's really around Windows 10 and IoT devices. And I do have a little intro video. So we'll roll that while we kind of settle down. Kind of give you a sense of what's going on.
Ever wonder what the future holds? Imagine if you could connect the dots to see beyond where your business is today to where it could be in the future. Would you begin to see ways to make improvements? Or see what once seemed impossible is now within reach? Technology is rapidly accelerating the transformation of your business. It's changing the way we work. Imagine if the most vital parts of your business were connected: people, assets, processes, and systems. Everything from your factory floor to the field. With the Internet of Things, they can be. And simple changes can transform your business right now. With the Internet of Things, you can extend your business's reach and make better use of its resources. Data that was once untapped is now an asset. Even the most critical issues can be solved in real time. You can see ways to make the most of every moment. The reasons why you should embrace the Internet of Things are clear, but how do you get started? We believe the Internet of Things begins with your things, the things that matter most to your business. Start small, from where you are today, and build from there. Make the most of systems you already have in place. Use familiar devices or services in new ways. Tap into the cloud for better scale and control. Microsoft can help you get started today. We can help you connect assets across your business using your existing technology, investments, and data. We can help you transition from today into the future so you can transform your business. Because when your business is more connected, the possibilities are endless. Welcome to the Internet of Your Things.
Alrighty, hopefully we don't all feel too seasick after that. Now, I also will take limited questions as we go through the session. So if you see something and you want to ask, then do call out. There is actually prizes for asking. But don't kind of like feel the urge to jump in for everything. If I feel the question is too long, then we'll kind of move on, okay? And I'm going to be around, I'm around over the Maker Den for quite some time for the rest of this week. Okay, so this session is kind of split up into two kind of major chunks. The first part, as you might have kind of guessed with that video, is a bit more enterprisey. So what are we doing and why is it kind of relevant to the Windows ecosystem? Why is it relevant to business? The next part of the session is going to be really kind of more the maker space. So how many people here have played around with devices? Arduinos, Raspberry Pis, ESP8266s, blah, 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 all those things. So maybe 40% of their hands went up. Okay, so that part's part maker. And also the thing that I love about this whole Windows 10 and IoT core is it's fun. And potentially if you're doing client development and you just want to break and you want to do something which is fun, it's fun. It's fun and it's incredibly frustrating at the time. So if any of you have done this stuff, you'll appreciate at times it's rocking when you see what you've done, but you're often battling hardware bugs and software bugs. And that's kind of the joy of it. But all up, you should really enjoy it and kind of get something out of it when you do these things. All the source code for my demos are sitting up on my GitHub. I chuck everything up there. It's my backup for as much as anything. And all the source code for the MakerDen is sitting up on github.com/MakerDen, which I think I've got a link up there as well. So this is kind of how the session's broken up. And I've got too many gadgets behind here. And something's probably going to go wrong. But anyway, fingers crossed. I won't will it to go wrong. Okay, so as I mentioned before, we've got the MakerDen. So the MakerDen is in the showcase area. It's over in the far corner. And it's an opportunity to sit down and actually play with the bits and play with Visual Studio and check out a few sensors and just kind of have a bit of a sense of what is going on. And again, all the source code's going up there. We've run the MakerDen quite a few times now. I think about 4,000 people have been through it and had to go on it. So give it a go if you want like an easy way to get on board and try it out and just see what this stuff's about. So the whole thing's been designed to be accessible, so you don't feel like you're starting from zero in terms of building out this stuff. Okay, in terms of kind of how I've split out some of these topics, I've kind of thought, well, what are the driving forces behind IoT? Because for many respects, IoT has been around for a long time. I would say probably a good 40 to 50 years. We've been doing process control systems and a whole range of things. I think one of the first devices was a toaster that was connected to the internet, or certainly up to the communications back in the 60s, I think it was, I guess prior to the internet as we know it today. Just talk about some of the opportunity and talk about the development, and then I've got some plenty of demos in there. So in terms of, I kind of mentioned before that the Internet of Things has been around for a long time. So what's kind of different and why is everybody talking about it now? And I would say one of the biggest reasons is really around commoditization. And stuff is just getting cheap. So silicon, microcontrollers, CPUs for that matter, is getting cheap. So you can now go onto eBay and you can buy the controller or sensor of your dreams for a couple of bucks and create up an idea, and it's accessible. Whereas if you tried to do this 10, 20 years ago, you'd maybe had to mortgage out your house to go and build something. So it's really accessible. So that's what people love about it, be it wearables, be it stuff that's going into mines, going to logistics, packaging, whatever it is, it's getting much more accessible, much cheaper. The other big trend, obviously, and I guess you can't walk away from this conference and not appreciate just the emergence of cloud and the commoditization of storage, of CPU, of memory, all those types of things. So those kinds of things are coming together. And I also throw up there 3D printing. I think that's really significant because it's going to make us be able to go out there and create things and prototype things and then take them off to Kickstarters and things like that, or organizations, and say, hey, look, this is a prototype of what I think I can do for your business. Whereas doing all that would have been hugely expensive and difficult even 5 years ago. The other reason is kind of organizations are hungry for knowledge. And I think that's fair across pretty much everything we do. We've all got this we've already got mountains of information. We're struggling with what to do with it is anyway, and hopefully things like cloud and business intelligence and machine learning, all those types of things will add value. But organizations are fundamentally trying to understand how people are using their products, how they're interacting with the organizations and things like that. And I will also say on top of that, there's a big push behind open source. And you can see that in Microsoft as well. A huge amount of what we're doing now is open source. We have stacks of projects up on GitHub. Things like .NET Framework have all been open sourced. So there's a real push inside the organization to do that. And on top of that, I would say the maker movement. I don't know if you've heard of this kind of idea, but it's kind of the hobbyist, the tinkerers. People are building stuff, and it used to be the men in the cave, or whatever it was, the woman in the cave, going off and building stuff. But this whole maker movement has really taken off again, and people are just kind of playing around with ideas and seeing what they can do. Sometimes just for the sake of seeing what they can do. Maybe with nothing an awful lot more in mind than that. So in terms of what we're aiming, what we're trying to do with the Internet of Things from a Microsoft perspective is enable organizations to kind of go out there and reach out to various services or devices or logistics or whatever it is that organizations kind of key businesses, and be able to kind of fundamentally instrument that and then connect it up into the cloud, then do something with it there, make it actionable. So things like machine learning really come into play with that, where you can have systems automatically detect what's going on and then make decisions based on the data you've got now, based on historic trends and things like that. And really what we're trying to say is when you're thinking about your business, it's very much about your things. And at the back of that movie, I think it said, kind of start small. Come up with an idea. Don't try and boil the ocean, he says, chucking in all these things. But come up with an idea that you think that is tangible to be able to kind of pilot the ideas out there. We talk to organizations and they're, oh, everything's going to be internet enabled, and well, maybe it will, but it's very much about trying to start with an idea. Just to give you a bit of an idea about the industry itself, they think about by 2020, there'd be around about 25 billion devices connected. Now, it's still a big number. Actually, the slide I think I had last year had 200 billion, so I think people have kind of readjusted themselves. But there's a huge opportunity, and you'll see in the next couple of slides where those opportunities can be. So you might think, oh man, there's never going to be out there. And again, in terms of a revenue opportunity, they think it's something in the order of a $1.7 trillion industry. And it's all about kind of interacting with things, environments, and again, it could be down the bottom of a mine, it could be in a retail store, it could be a whole range of places, and people and those kind of whole interactions that are going on. So to give you an idea what Microsoft is doing, so we've done a huge investment in Internet of Things and really kind of enabling our organization. So out at Redmond, we have a huge campus out there. We have something in the order of 88 acres, 125 buildings, and we collect, and that's 500 million data points per day that go into our processing center, and we have automatic actionable items. And that is things like sensing if somebody's in the room. It's around what doors are being opened, security systems, air conditioning systems, heating systems, all those types of things. All that data we collect out of our buildings and we push it into our data centers, into machine learning, and we do stuff with it. And we're saving around about 10% of 10% energy savings per annum. So we're really making quite big use of these technologies ourselves. I love this one. The car's really cute for one thing. But when people talk about 25 billion, you start thinking about, oh, you know, how many people are there in Australia or things like that. One of the biggest sectors that I see in Australia is actually around agriculture. And I think already cattle, I think they're all tagged with some sort of device on them in Australia. I don't believe sheep are. But I've spoken to people who are looking to tag fish or a whole range of things going on there. So you start to see that 25 billion devices out there collecting information may not be that unrealistic when you start thinking about all these opportunities. So I'd say when I see in Australia, I particularly see around agriculture, everyone's trying to get smarter about crops and irrigation systems and watering systems, things like that, and also dealing with animals and kind of dealing with them kind of through their life cycle. It's a nice way of putting it, isn't it? The other big sector we see, and again, these are real, and you probably see these on television now, where if you put a certain device into your car and you instrument your car and have that data going back to the insurance company, then they will reduce your premium. They'll see that this person drives like this, or the car is garaged, or whatever it is, they've got sensors in there for a whole range of things. The motor industry is doing this now as well. They're looking at preventative maintenance. Okay, the car is vibrating in a place that it shouldn't be vibrating. Maybe it's time to recall these cars and or actually do something about them. So you kind of see these sectors here, and I'm sure these touch on certainly the insurance and the finance sector in particular, touch on a whole different way of in which we can kind of reach out to our customers. So as I said before, this session is predominantly around Windows 10 and the IoT core, and to kind of give you a bit of a sense of what we're trying to do with it, because there are a whole range of devices out in the marketplace, some from the smallest embedded devices, really low power, whose maybe like my Fitbit, which I'm wearing, its transmission range is to my phone, my Bluetooth 4 phone, all the way up to some more sophisticated devices which are doing process control systems. So there are a whole range of devices, and again, I'm trying to kind of position where I think Windows 10 fits in. So first of all, when you're building for Windows 10 IoT, the platform, you are normally going to be building out there for the Windows Universal Platform. So applications that you're building out there for Windows 10, they're going to run on a Raspberry Pi, for example, or Minnow Board Max, devices which are running Windows 10. The other thing that we've done a huge amount of work on is this universal driver model. So one of the biggest banes of anyone's, or particularly OEM's lives, is building device drivers that really kind of reach out and touch the hardware. We now have a universal model where those work pretty much all across all the devices that support Windows 10. And on top of that, and I think this is one of the key things for our organizations, it's part of the Windows ecosystem. So it's part of the update system, it's part of the management, it's part of deployment, it's part of security, part of certification, or part of certificates, all those types of things that when we come to manage our organization's infrastructure, a Windows 10 based IoT device just naturally fits and participates in that whole kind of management and security infrastructure. So that's, yeah.
Does this mean this Windows 10 is taken over Windows Compact Edition?
Okay, the question was, does this mean it's taken over Windows Compact Edition? And actually for now, no. Because Windows Compact Edition is the only hard real-time operating system we have. And that will continue to be the case. And for that, you get a shirt. Yes, so we do have, so you would have seen these in particular process control systems, and they are hard real-time operating systems. There is work afoot around that space, but yes, Windows 10 is not a hard real-time operating system. I've kind of mentioned enterprise-grade security, and that's again one of the things that when you start looking around the Internet of Things, you start thinking, oh man, these devices out here, oh, they're so cheap and blah, blah, blah. You start realizing they've got real limitations, like security, being able to do SSL, being able to call HTTPS, being able to talk to Azure securely, a whole range of things out there that really small devices can't do. But things like Windows 10 IoT Core may provide a hub inside a factory floor, for example. And you may have these small devices which are talking over maybe less secure protocols to a hub, and then when that data switches out onto the internet, that's then going across in a highly secure fashion. Yo.
What's the difference between Windows Compact Edition and Windows Embedded? Is it the same thing?
The question was embedded versus, look, embedded, the naming convention's gone. In fact, the next slide will answer that question. Yeah, so we do have something, we have had, and maybe in traditional Microsoft style, lots of names for different things. And, but they are all coming together, those namings, and the platforms are coming together for that matter as well. And again, the whole thing we're trying to do around this is really around device connectivity and cloud connectivity. So really bridging that world of small devices out into the cloud where you can start doing something really useful for that data. Okay, so editions. So now this used to be the world of embedded. So we have now Windows 10 IoT Enterprise. And I can't remember what its old name. It was probably something like Embedded Enterprise. And you can see it's there for process control systems, process control machinery, kind of really key critical bits of environment. And it will run both universal Windows applications and Win32, and you've got all the management and infrastructure around that as well. Now, this, I think, used to be called embedded mobile or embedded phone. Mobile, I think it was. And this is another SKU we have. So bear in mind, these SKUs will often go into manufacturing systems. They're probably not necessarily anything you'd buy. They're more going out to an OEM. And we've got Windows 10 IoT Mobile, and that is going to things like scanning devices or maybe point-of-sale devices where people are coming along and taking scanning and dockets and things like that, or stock control or things like that. So that's where the Windows 10 for IoT Mobile sits in. And it has a shell, so you can switch out applications and things like that. It's locked down, and it will run universal window platform applications only. So the first one will run Win32, and probably there for a lot of legacy stuff. And the one that I'm probably going to talk about most is this thing called Windows 10 IoT Core. And that is meant for really small devices. And you'll see, while I'm on the devices, you'll see that some chips are purely x86. The mobile is as ARM, and the IoT core is x86 and ARM. So the different kind of SKUs out there. And the IoT core, you can see it's geared towards low memory footprint, low storage. It runs a single application really, or single kiosk-based application at once. You can run kind of background applications. It runs universal Windows applications, and it's kind of built out there for low-cost silicon, things like the Broadcom chips and things like that. Yeah.
Just in the near future, when devices, handheld devices are running, 64-bit and larger storage capacities, will that mean that vector will have to change with it? Or
Yeah. So the question.
those devices fall into a different vector?
Look, the question was kind of around 64-bit and sizing and things like that. I kind of made a comment to someone a couple of days ago that in 2 years' time, I suspect that we'll be buying silicon for a $5, which runs 64, which has a couple of gigs of RAM. And these specs will obviously change over a period of time, but that's kind of where they're at the moment. Yeah. Okay, so we have also, in terms of release cycles for the stuff, so the Windows 10 for IoT Enterprise, we launched at the same time as we launched Windows 10. So there has not been an update. So with Threshold 2, hopefully you kind of got Windows 10 on your device, and Threshold 2 came out last week or the week before. So there's been no particular update for that. The same applies for IoT Mobile, except we've released that to OEMs. One of the things that we've done is down on IoT Core. Now, there's actually been some really nice changes in IoT Core. So one of the first ones, and you won't see this kind of coming through really for another month or so, but things like automatic updates has been enabled. If you're an OEM, you will be able to control that update process as well. So if you're someone that they're building that, and you'd say, well, I don't want Microsoft to be pushing out everything out there. I want to control it, manage that. There'll be the ability to do that as well. The other thing that we've done is we've made it Arduino wiring compatible. And that's really significant. Sorry, there's two things. We've made it Arduino compatible, and we've also made it Raspberry Pi Raspberry compatible. So the way that you interact with GPI pins and things like that, it works the same as it does on Raspberry. There was a few pins and things like that which you wanted to get at on Windows 10 Core, the first version, and it didn't work, and it was really frustrating. So there's been a lot of really good work done in the last 6 months about getting compatibility around Arduino ecosystem and compatibility around the Raspberry Pi ecosystem. But also fundamentally, this whole business of being able to manage the updates. It will be the whole same process. When you take this, you go to your system image, you say, look, I need a system image created for my desktops today, and they go out and you create a standardized desktop. They will be able to do the same with the Windows 10 IoT Core. They will say, well, this is my standardized, and these are the apps on it, and these are the services on it. They'll put it onto an SD card or they'll flash it out or whatever it is, but it'll be the standard part of the way in which people deal with Windows. And that's kind of like a really big thing, because most people don't want to have another set of ecosystem to manage. Now, Windows 10 Core, there are 3 commercial platforms, of which we just announced the Qualcomm one, or actually the Qualcomm one released into beta a couple of weeks ago. So we have IoT Core running an x86 on top of boards like the Minnow Board Max. It's an x86 board. It's a low-end Atom-based chip. We have Qualcomm, who built it out in their Dragon 400C, I think it's called. And we obviously have Raspberry Pi. Now, there are some subtle differences into the way which we've done this. And just keep in mind. So the boards that I've mentioned so far, the Minnow now Board Max, and the Raspberry Pis, and the Qualcomms, they are really developer boards. They're prototyping boards. If you then say, look, I want to take this and put this into production, then you would typically go along to someone or an OEM and say, okay, this is a chip set we do. And when we go and build Windows 10 IoT Core, we build it to chipsets. So we build it to the x86 and we build it to the Qualcomm chip. And then you go along and say, look, I want these chips, and someone will go off and croft up a board for you, and then you go and put them into your trucks, and life will be good, and you put your application onto it. At the moment, there is a slight exception to that with Raspberry Pi. With Raspberry Pi, we build to the Raspberry Pi, to the whole device. But there is actually some interesting changes afoot with that as well. As Element 14, who are one of the major distributors for the Raspberry Pi, and I think they manufacture as well, is that they are also going to do a customization service. So again, I've talked to people who say, look, I'm building it on Raspberry Pi and I want to stick it in the back of my lorry. I don't think they're really ruggedized devices that you put in a lorry and they probably bounce around and the SD card would pop out and things like that. You'd go out to somebody who'd go and build you a bit of silicon with the Raspberry Pi on it, and you'd customize it to your needs, and then you'd put your application onto that and distribute it to where you want it to inside your organization. Okay. So I've got a funny feeling this slide has been up on a lot of talks, probably more last year than this year. But hopefully everyone's aware, thank goodness, we've done a huge amount of work around converging our development platform. So if you're building out for phone, if you're building out for Xbox, or if you're building out for desktop, they are the same API. And what has been added into this is Windows on devices, or Windows 10 IoT Core is now part of that family. So you can literally pick up some code that you developed for your desktop application and just drop it onto your Raspberry Pi and it would run. And I have done that just because I felt the urge to do it. There are some limitations on it. So on the Raspberry Pi, for example, there isn't the hardware graphics acceleration. So you can't go and build a XAML-based application which has got all singing or dancing UI and things like that and expect it to render really quickly on a Raspberry Pi. So there are some kind of sensible things because you're dealing with a smaller device. But fundamentally, all these devices now participate in the universal Windows platform, and they are the same. Now, and that forms the core. Now, there are what we call extension SDKs. If you've done anything around universal platforms, you'll know that there are some extension SDKs. So there is extension SDK to get at GPIO ports, for example. I'll talk a bit more about what those are. But there are some very platform-specific sets of APIs. And if you want to build a universal app, you'd normally say, does that set of APIs live on this platform that I'm building to? No, this doesn't have a GPIO pins exposed. Then carry on. Don't try and turn a switch on. Okay. So in terms of application development, as I said, it's really pretty much, except for that enterprise SKU, it's all Windows or Universal Windows platform development. In terms of tools, it's Visual Studio 2015, Community Edition and above, so it's free. You need the Windows 10 SDK, and in that SDK, there is the image of the operating system that you're going to push onto the device. And again, you go up to dev.windows.com, and you'll find it up there, and that pulls down, and there are also some templates that you pull down into Visual Studio. Now, there are two styles of applications that you can build. You can build headed applications, applications which are pushing out some sort of UI, and it could be a kiosk application, for example. You might be building something funky, and you want to put a Raspberry Pi or a Minnow board or a variant of inside a kiosk and have a point of sale, for example. So you go and build a headed-based application. But predominantly, the applications I think that will be built will be headless. And they will typically either be streaming data up into the cloud, or you'll control them from another device, like a phone, for example. You would go and surface the UI of an IoT device onto a device, onto your tablet, onto your Windows, whatever it is. But that's typically how you would do these things. There is also a management interface. How many people have dropped down the image for the Raspberry Pi for Windows 10? Okay, relatively few. Okay, so there's also a management interface, a web interface, which I'm going to show you in a moment. And in there, you can go and configure up the Windows network, time zones, languages. You can shut them down the system. And for the really diehards, there is also PowerShell integration. If you really, really want to feel some pain. No, it's actually pretty cool. You don't run PowerShell inside the device. You run PowerShell to connect to the device and do stuff on it. So it's not kind of hosting up PowerShell internally, but you'd go and set it to, you might want to go and set up a standard configuration, in which case you might use PowerShell to go and kick off, connect to the device, and then go and set something, a whole range of settings on there automatically. So that's kind of what you would go and do with a PowerShell integration. Okay, so a lot of the questions I've been asked of recently is, where the heck do I start? Because people see all this stuff and they want to kind of get out there and start building some things. So the first place to go to is the Dev Center. I promise you my demos are going to be more than just web pages. And up on the Dev Center, you've got, if you go and click on Explore, you'll see you've got all the places out there, and that's got the samples, it's got the training kits, it's got everything. And if you scroll down a bit further, you want to get started, and this is where you go and select your devices. And I said, those are the boards, and you go and click on that, the appropriate image, and there's a few more things down there. We're going to do Raspberry Pi, and there is fantastic detail. If you looked at this a while back, you thought, oh my goodness, the level of detail, and we've actually done a lot of work to reduce the complexity as well. So a lot of the process, go and click on it, put your SD card in there, and you're off. And it's really good. And it'll tell you where to go and down the developer tools, how to go and set up, where to go get the images from, how to go and configure it, how to change the default password, all that stuff is sitting up there. And the other thing that I really like up on this page is the documentation and samples. And again, sometimes I know you kind of go hunting and you can't find stuff. And samples up there, it's really good. So you'll find samples up there building stuff in C#, Python, Node.js, there's C++ examples out there. Whatever takes your fancy for building this stuff, there's some really awesome samples up there and great place to get started. Plus, there's a whole lot of documentation and tutorials. The next best place that I like to go to is something up on a site called Hackster.io. So if you go to Microsoft.hackster.io, and up there you'll find a tremendous range of projects. And again, this is more answering, a lot of people say to me, where the heck do I start? And if you go up into these pages, I'm just picking one random, you'll find as part of what you need to do with Hackster is you need to go and define the schema, how the board is laid out, a whole range of things on there. In fact, this site doesn't entirely render as it should. If I go, and you'll find that this is how to wire up the boards. A lot of people say, man, where do I even start? Well, Hackster.io is a great place to start if you want to kind of start playing on with these things and thinking, what's a voltage divider? What's a logic level shifter? And all these types of things out there. What's an ultrasonic sensor? How do relays work? Go and check out these sites because it's an awesome set of resources to get up and running and actually start doing stuff. And I tell you, that's probably often the number one question I get is us, where do I start? Okay, so now we've done the where do I start. What I've got up here is a couple of devices, and if I'm brave enough, and I've got to do this sooner or later, you'll see I've got a couple of devices sitting up here, and I've got a couple of Raspberry Pis, and what I'm going to do is connect to them and show you how you manage these things. So when you install the SDK, you get this thing called a Windows IoT Core Watcher. And you can see that there are 3 devices. There's one sitting out over in the data den, over in the showcase, and I've got 2 over here. I've got a robot, and I've got one called DG, because it's my initials, and at least I can remember where I am. And if I come and right mouse click on that, for one, it's easy to get the IP address, MAC address, which can be quite handy. But you can open up the web browser. And what you'll normally done, because I've already pre-configured, you'll be throwing up an authentication dialog box. And the default credentials are administrator and password as P@SSWRD. That's all documented up on that website. And the number one piece of advice they say to you is change the default password, particularly if you're going to put it out on the network. And then once you're up on there, you can see that for one thing, you can shut down, you can reboot. You've got the system time up there, which kind of looks, I'm not sure what time zone that's in. And I can look at the apps. So these are the apps that are currently running on this device. I can go and look into the processes that are running in there. So you can see what all the processes that are running. As I said before, it's Windows. This is a thing you get when you're going to go into Process Explorer, Task Manager on top of Windows. You'll see the same processes there. You can go into performance. And this machine here is just trundling along. You can see what the memory utilization of this thing is. These Raspberry Pis, they ship with a gig of RAM on them. So you can do a lot and get in a gig of RAM. And you'll see that there's plenty of memory. At the moment on the Raspberry Pi, we don't have hardware accelerated graphics, so there's just the Microsoft Basic renderer. But you can go through there, look at dedicated memory, look at I/O, look at network traffic, all those types of things. So it's pretty cool, just to kind of understand what is going on that device. Then there's some stuff around debugging. It's kind of more kernel level debugging. You can go across to devices, and you would have seen a familiar tree. And you can see that there's what devices supporting on there, the power management, volume management, network devices, audio, all those types of things. It's kind of pretty much a standard way in which you'd kind of deal with a Windows environment. And again, it supports a wide range of devices. Clearly not as wide as range as a PC would. But there's pretty damn good Bluetooth support out there now, so Bluetooth 4. There's pretty good audio. You can hook up a microphone. I can't show. I'll talk about the demo, but I can't show it to you, partly because I couldn't quite get it working. I wasn't sure with the microphone I had. There's a whole stack of devices, and again, if you go up to, and you want to know about these, we've got to go to set up your device. Sorry, set up your device. And down here, there are some release notes. And in the release notes, they will link you to the hardware compatibility page. So if you're wondering and where that information is, it's sitting up there by the images. I think I'm on a slightly different version. Okay, yep. And finally, you can go and set up networking. And the Raspberry Pi, for now anyway, supports two Wi-Fi dongles. It supports the official Raspberry Pi dongle, and it supports a new one by TP-Link. And they're both around about $20 and things like that. And all readily available in Australia too, by the way. And I've got a little bit about that later on. And look, you can see the IP addresses and MAC addresses and all those types of things that are going on with the network. Alrighty. So that was just a very quick whirl around how do you actually kind of deal with these devices once they're up and running. Literally, you create your SD card, put it in, hook it up to the network, turn on the power, up it comes, and the IoT core watch will discover it, and you're off and running. Okay, so in terms of actual development, I kind of hinted at this before, but you can develop in pretty much what you want. So there's C#, there's VB.NET, there's C++, there's Python, Node.js, and VB.NET, and probably a few others. I suspect you can even do an F#. You can also have mixed projects. So for example, you could pick up an Arduino wiring project and drop that C++ and adding a few minor changes to that. You would have that Arduino library participating in that Windows Universal application, that Universal Windows Platform application. So you can really take code from a whole range of sources and actually go and build that. The other thing about, and this is again pretty unique, is that there's a full remote debugging. So you can set breakpoints and breakpoint on your device and understand what it's doing. And often if you've been developing these things, you'll appreciate when you develop for IoT devices, often you're developing in the dark. You don't really know what's going on. And you kind of guess, and you kind of go through it. Beg your pardon? No, actually, I'm not 100% convinced about that. Now, that's one I didn't get around to looking at, I'm sorry. But I'll tell you what. I'll give it to you later. Okay, you can catch it. God, can I throw it? Not as far as I could have. Okay, so there's a full remote debugging experience, and there is, as I said before, an IoT extension SDK for building universal Windows. And that exposes GPIO. So GPIO stands for General Purpose I/O. And those are the pins that you see on top of these boards. And the whole idea behind that is that you can control the external world from those pins. You can go and change a voltage. You can go set a voltage high. On the Raspberry Pi would, you go and set it to 3.3 volts. Or you go and set it to 0 or ground. So that's kind of what GPIO is about. And it's kind of, you can control relays and all those types of things over GPIO. The other thing that we support is what's called I2C or I2C, or you hear people call it a slightly different way, and that's a bus. And think of it like a token ring or an Ethernet. You've got devices which effectively sit on a bus, and they have addresses. And you talk on the I2C bus, and you say, I'm talking to address 70. And here's a command for you, and I want you to go and measure the temperature, or measure the air pressure, whatever it is, and that will reply back. And you might have other devices sitting on that I2C bus. So it's a bus. The same thing really goes for SPI. And if you have devices that you can put on SPI, you can do chaining of multiple devices, or you have effectively what called two devices, or two channels, chip select 1 and chip select 0. And you can get at things like that. So those are the core bits of framework that we put in there. Now, on the Raspberry Pi, there is no ADC, which stands for Analog to Digital Converter. There is none. So there is nothing in the spec. The Raspberry Pi, when they built it, they didn't go and put an ADC on it. But what we have done is we have created infrastructure to support ADCs. So you can go and put a chip on your breadboard or whatever it might be, or your circuit that you're building up, and then have an ADC driver that you might write participate in the infrastructure that we provide for ADCs. The same thing stands for pulse width modulation. There is really no chip support for pulse width. And pulse width are used all over the place. They're used for controlling motors, servos, and all those types of things. But again, the same thing applies. There is infrastructure. So people are now writing drivers to that infrastructure. You say, look, I want to create a pulse width. There's a lovely Adafruit one, which I think maybe has 12 pulse width. So you drive a robot or a whole set of engines or a servo on a process control system, and you do it over pulse width. And then good old UART, so good old serial support in there as well to be able to build things. Now, there is also, as I mentioned before, Arduino wiring support has come out with the latest iteration of Windows IoT Core. And again, it's amazing because there's this whole, the Arduino ecosystem is very rich. It's really quite mature. And you can pick up those projects and now really effectively drop them into your Windows 10 project. The other area that's really cool on Windows IoT Core is speech services. So I don't know if you realize that you can go and build an application on your desktop, which obviously there's Cortana and things like that, but there are some fundamental APIs in there which enable you to go and do text-to-speech and to go and do voice recognition. So we have synthesis and we have recognition services that are built into Windows IoT Core. So they're sitting on the Raspberry Pi on a $40 piece of kit. So we've got speech services in there, and we've also got a whole range of things around making it really easy to connect the devices to the cloud and things like that. So all the security protocols. It has SSL. It's a device and a chip that is capable of doing SSL encryption. So you can go out there and build those kind of things with confidence. Now, the other thing that we support in there is something called AllJoin. Has anybody here heard of AllJoin? There's a few hands going up. So I'm going to talk about it in more detail shortly, show a little demo of that. But AllJoin its main role is to address device interoperability. So everyone's building out IoT devices, but they all talk different languages. So we're kind of back to square one in some respects. So AllJoin is about how do we have a common language, a common way of discovering things, a common security, a common way of connecting and advertising services and things like that. So that's what AllJoin's about. Okay, so the first demo that I'm going to show you is this. It's a headed demo. So it's as I said, there are two types of projects, and it's a little radar system, and you kind of get it what's going on. Now it uses something called pulse width modulation, and just to kind of give you someone's probably going to say, "Oh my God, that's a terrible description," but pulse width modulation is used for things like servos. So you can be able to move a servo around, or you can move motors around, and things like that. And the way they work is that you say, I've got a frequency, and let's say my frequency is 1,000 times per second. So you'd say, in 1 second, I'm going to divvy that up into 1,000 units. And then inside that, each one of those units, you have what's called a duty cycle. And you'll say that in that segment, I'm going to turn a voltage on for 50%, for example. And then and the rest of that cycle, or the rest of that thousandths of that second, I'm going to turn it off. So it's basically a way, and that duty cycle is what things like servos look at. So they say, man, if you've got a duty cycle of 10%, I'm going to swing the arm 10%. It doesn't quite work like that, but anyway. If you swing it to 50%, I have a duty cycle of 50%, maybe I swing the servo 50%. And if I have, in that complete duty cycle of 100%, then I'm going to swing the servo motor all the way around to full swing. That's fundamentally what pulse width is doing. So, and on top of that, what I've got is, and I'll show you how these things work. Now, before I said that we don't have any pulse width support directly inside Windows IoT Core, particularly the Raspberry Pi, because there is no pulse width electronics in there. So I've got a device here, and what I've done is I've stuck on top of this, I've actually put an Arduino, because Arduinos do actually have really good pulse width. They also have really good ADCs on there. And this one actually here is an Adafruit Trinket. And it's the 3.3 volt version of the Trinket. They do a 5 volt and a 3.3 volt. And the reason you want the 3 volt if you're going to do this is because a Raspberry Pi is fundamentally a 3.3 volt system. And yes, there are going to be some devices which want 5 volt, but if you start pushing 5 volts back into the Raspberry Pi, you'll be very quickly going back and buying another Raspberry Pi because it will fry it. The other device that I've got over here is an ultrasonic sensor. And they're like a bat. They're like bats. They send out a ping and they listen for the reflection. And they say, well, at sea level, the sound travels at a certain amount of time, and you know that by the time it gets back, if you measure that time, divide it by 2, figure out the speed of sound at the sea level, you can figure out how far an object is away. So that's kind of how that works. Now, that device does rely on 5 volts. So you've got to push it 5 volts when you send what's called a trigger, and it echoes back at 5 volts, and you have to do what's called a voltage divider. So don't kind of get really funky and just say, oh man, I'm sure that guy on the stage just hooked it up. And you'll see a couple little resistors over here, and they're just dividing it's actually 2/3. I'm providing 2/3 of the voltage from that little sensor back into the Raspberry Pi. So 2/3 of 5 volts is 3.3. So that's what that's about. And if I come into Visual Studio, as I said before, there are 2 types of projects that you can go and build. And if I go into New Project, thank you. Please don't hesitate to keep reminding me. Yo. Beg your pardon?
You say you're stepping down the voltage from the sensor to the Pi.
Yeah.
How are you stepping up?
No, you don't need to because there's a 5 volt output.
Oh, is that?
Yeah, so there's 3.3 and 5 volt output. You just got to be really careful. You think, this one's 5 volts, and you forget it's pushing 5 volts back in. Yeah, that's where you got to be careful. Yeah. So for building out universal apps, you would just go and build you just go and click on create a universal app as you normally would. And that would create you a headed-based application. The other style of application down here is what's called a Windows IoT Core application, and that would build you a headless application. And that's as much as I wanted to show you on that. That was a really cool demo. Because there's way too much code. And I'm not even, thank you, Stephen. You're too kind. All right, yo.
Sorry, does that still run IoT Core, the same version, even though it's headerless?
Yes. So they're purely one's going to try and throw, what the headed one does, yeah, so what the headed one does, it will build you up. As you can see over here, mainpage.xaml. It's just building up, just a regular app that's going to project out on, in this case, the HDMI port. And in fact, I'm pretty sure I opened this because that always takes a bit longer than we'd like. But in this application here, I've got some XAML. And what it's doing is using something from the WinRT XML, so XAML toolkit. And there's a nice little pie slice bit of a control that you can use in there. So it's, as I said, building out the UI is exactly the same as you go and build it out on the desktop or tablet or whatever it is when you're building on for Windows. It is the same. As I said before, though, be a little bit careful because it's not accelerated graphics. So you don't want to have lots of renderings going on. You want to be pretty judicious on what you want to go and do. The other part of this project, and in here, and in my main page, I've got basically a bit of initialization. As I said before, I'm using an Arduino as kind of like a bridge. So I'm sending a message over I2C. All the code will be available over I2C from my Windows 10 IoT Core application, sending a message over the bus to my Arduino. My Arduino's listening on that, and it's taking commands to swing backwards and forwards the servo. So that's kind of what's going on there. And there's a bit of maths in here. It's just kind of managing the toing and froing of the servo. I've got a distance sensor, a bit of code in here to go and manage the acoustic distance sensor. Basically, all it's doing is it's raising a voltage on the sensor, drops it again, and then raises it. And that puts the sensor into sensing mode. It sends a ping, and then you quickly go waiting for the echo to come back. And when the pin goes high, I think it is, then you know the echoes come back, and you can time that's how these things work. You can you can figure it out down to very high degree of accuracy. Beg your pardon?
Sorry, did you write that distance sensor class, or did you get it from GitHub?
Actually, I did write one. The one I'm actually using here is pretty much the same as mine. At the back of the project, I've got all my device drivers that are written, of which this is one of them.
Oh, okay. So
Yeah.
this is from GitHub.
Yeah. The other really cool thing about it, as I mentioned, this project has also got some Arduino code in it. Now, there's a really cool add-in for Visual Studio by a company called Visual Micro. And you drop that down, and you can start doing Arduino development inside Visual Studio, and you get autocomplete, IntelliSense. It's wonderful. So if you play around with Arduinos, and you're going to go to the IDE, and man, I can't remember what methods are on there, and all that type of stuff, you can use that. So there's a bit of Arduino code, and all the Arduino code is doing, I come in here and I set up, I've got a servo that's sitting on a particular pin, and I'm listening on the I2C bus. And this thing is what's called a slave. And it's listening on hex 40, which I think was 70 or 60, I think it is. So it's basically a bit of code that's running on that little device, and that's kind of going to manage the servo. So what I'm going to do now is I'm going to, I'm quite sure the order to do this in, but we'll jump across here. So there goes IoT Core running on my Raspberry Pi sitting on the table here. And what I'm going to do, and all I'm doing is clicking on debug, and I deliberately didn't. So just so you see what's happening now. So all I did was I just hit on and debug. So I think I did start without debugging. So what it's doing here now is, and I'll switch across here, and I said, this really kind of wants multiple screens. But you can see now that I've got my little ultrasonic sound sensor swinging around. And if you can see maybe just in here, you can't, there's a little red thing blinking. That basically is just indicating that the message has come from Windows 10. And so it's been sent there. And if I go and switch back to the actual Raspberry Pi in Windows 10, and you'll see that if I go and put my hand over here, you can see various traces of the radar. It's pretty cool. And as I say, all the code's sitting up there. Now, I didn't write this demo, just so you know. I nicked this demo, and I changed it a reasonable amount. And I'm going to repost it, plus put the fixes back up online. But I'll have it all up on my GitHub as well. And I'm going to repost it back up into Hackster. So all the code's there, and it's really cool. So for the price of about $40, the ultrasonic sensors cost about $5, maybe less, off eBay. The trinket maybe costs $15. And you can get out there and start having a lot of fun and really kind of get your head around what it takes to go and build universal apps, for one thing, and what it takes to interact with the physical world. So I just thought, when I saw this guy, I thought, oh man, that's a rockin' app. Okay, so that's what's going in there. So there's a couple of things in there. So we had Windows 10 Core talking to an Arduino over an I2C bus. The Arduino was doing the things that it's really good at. It's a real-time operating system. It's hard real-time, and it can do really precise timing. Windows 10 is a general-purpose operating system. It's got memory management going on. There's processors going on over here. There's network stuff going on over here, and things like that. It's not really an operating system designed to go and do really specific timing. The way you'd normally do it is you'd offload it to another chip. And you can get chips that you'd hook directly up to Windows 10, or you go and offload it to another board. Okay. Alrighty. Okay, so the next demo I'm going to show is, this is going to be a headless app. So you remember all I did was I selected IoT Core when I went and created a new project. And this one is a robot, and this is all me, I have to say. And this is a robot that I kind of had a lot of fun building out and playing. And it uses those acoustic sensors, and it's a bit like one of those vacuum cleaners that run around your house, you know, those things that kind of do the vacuuming for you and kind of sense what's going on. But all robots should be speech enabled, because clearly that's what, you know, want to be able to talk to them. What I really wanted to be able to do is talk to the robot, but anyway, I didn't get that going. Now, it uses speech, and out of the box, the media element is part of the XAML namespace. And you cannot get at the media element directly inside a headless application. But the good guys in Microsoft IoT, so we've got a lot of people churning out code for these things and kind of filling in the gaps. They have built out a universal media engine which works really well in headless apps. So what I'm going to do is I'm just going to hopefully switch this thing out. And this is one of the first demos I've ever done which actually has BlueTack. I never thought I'd do a demo with BlueTack in it. Anyway. Alrighty. So this is, I've got to be a little bit careful how I move this thing. I've got something. Okay, so what it is, it's got 3 of those sensors at the front of it, and they work exactly the same way as that radar works. Under there is a Raspberry Pi sitting in there, and there's also something called an H-bridge. And an H-bridge is really for driving high current things. So you can switch from a low current to high current, and you can drive motors and stuff like that. And so what I'm going to do, just make sure I don't forget the bits and pieces I was going to show. Yeah. No, I'm on the wrong screen. Okay. So again, this project is sitting up in my GitHub, and this is called Rover the Robot. And in fact, he did get called Bruce because I was describing that it kind of a bit like a bat, and Batman and Bruce played Batman, or Bruce. Well, that's kind of how to get called Bruce. Nothing particularly Australian. And this is a headless app. Now, if you're building a headless app, and it's a bit of a shame the templates don't do this by default, the first thing you've really got to do is you've got to tell the operating system, you've got to get what's called a deferral. And that basically tells the operating system that when you kind of get to the end of this bit of code, don't chuck me out. I'm here and I actually want to do some stuff. And so that's the way in which you get a deferral. You tell the operating system, I've got stuff that I want to be able to do in the background. And then in my main class over here, I do a number of things. One, I initialize the speech engine. I initialize the all-join engine. I'm going to go into all-join a little bit more in the next part of the talk. I init the robot, and I'll explain what I do, and I start sensing. So on the speech, as I said before, it doesn't get much simpler, I have to say. You just cropped up a new version of the media engine. You initialize it. I'm also initializing the speech synthesizer. And if I want to make it speak, there's a method down here called speak. And I just wanted to, if I'm already speaking, don't ask me to say something else. So that's all that bit of logic's doing. And then over here, I'm passing in a string. You can also pass it in a bit of XML, actually. And it's taking that and it's synthesizing that. and then it's passing that stream across into the media engine. And literally, it's kind of 3 lines. I'd love to say it's a bit more. And you await it, because you've got to give it a chance to say something. If you go straight back to your code, these things kind of will want to kind of find a gap in the conversation before it kind of says something. So that's how the speech works. I'm not going to talk about the all join bit at the moment. And I've got this thing over here called Robot Manager. And Robot Manager, it starts up 2 instances of the motor class. And the motor has 2 pins on it, because you want to be able to make the motor go forward and backwards, or the other way, depending which way you're looking at it. So you've got 2 pins here which you can change the direction. So if you have 1 pin low and 1 pin high, it goes backwards. If you have 2 pin high, it goes, forwards. If you have 1, it goes the other way. If you have them both, it stopped. And that's kind of how you control it. So you've got 2 pins, and you change the voltages on it, and you change the behavior of the motors. And then the ultrasound sensors, they sit, again, on a pin. So you remember I said before, if I just get that to pop that up, there's a trigger pin. So that's a pin I'm going to send a message down. I'm going to raise the voltage, and the echo pin is I'm going to be listening on that. And when the voltage comes back, I know that I've finished measuring. And as I said before, I've got 3 sensors on there. And then what I'm doing, the robot has two modes. It has autonomous mode and manual mode. And then in autonomous mode, what it does is it goes around and finds the closest object. And literally all I'm doing down here is I've got a collection of 3 sensors. I go around them, go and find out how far away the closest object one. The person or the object, the sensor has the closest is the winning one. And then in my logic, I go and say, if there's a sensor really close on the left-hand side, then turn right and get away from it. And I have 2 types of turns. I have a really sharp turn, because heck, there's something really close, or kind of like a slightly more graceful turn. And you're more than welcome, by the way. I'm going to have this over in the Maker Den. If you look at my algorithm and think you can do much better, you're more than welcome to come along and rock up and give it a go. And I said the thing will be there, and feel free. But you can see I had like a really straightforward one. If there was something on the left, then turn right. If there was something there, if there was something on the center, you can see I've got various approaches, including all the way down to reverse. I actually had an infrared sensor on there, which I don't have at the moment. And that's kind of how it works. And what I'm going to do now is I will deploy this onto the robot. And I'll just start with that debugging. So this is just pushing it on there, and hopefully I have the motor turned off. I think I do. Okay, so the deployment's starting. So down the bottom, you can see a little green thing. You've got to have the patience of a saint for some time for these things, because you're always pushing to a remote device. It's a bit like building for a phone or a device that you're building for remotely. You're pushing the code on there. Okay, so in theory, my code is up there. It is, it's running. And I'm going to explain a bit more about this app shortly. But at the moment, it's in manual mode. And what I'm going to do is I'm going to put it into autonomous mode, which is going to start the sensors. And hopefully, if I move around the sensor.
Right, center.
And you see,
left,
as I'm just basically moving my hand
left,
around.
Right.
And the speech
right,
is just an awesome way to debug
center,
it, to kind of
left,
figure out what's going on.
center.
As I said, all I'm doing is I'm chucking the words center, right, and left. And the speech synthesis engine is just doing the rest for me. It's absolutely awesome. And for those, I don't know, if I hopefully move that across. And
center.
yeah. And you'll see the motors. Can you see
Right.
the motors? My hand's
Right.
right in the way. So if I
Center.
move my hand over to
Right.
the right-hand sensor,
Right.
you can see that it changes the
Right.
motor direction.
Right, center, right.
Anyway, really cool
Center.
stuff. And I said,
Right.
if you've got some things you want to play around with, some ideas for building autonomous robots, feel free to rock up. And all the infrastructure, all the code sitting up on GitHub as well. So that's the kind of thing you can do. So that's an example of a headless app. So you're deploying that application across onto the device, and it's obviously starting up. Now, what you can also do is with PowerShell, that's where the slightly painful part is, you can come along and you can define auto start for 2 apps. you can auto-start a headed app, and you can auto-start one headless app. But a headless app, or those apps, can also croft up other services behind in the background, and they can communicate and all that kind of infrastructure that's just built into Windows 10. So that's kind of what goes on with that. Hopefully that switched back. Yep. Alrighty. So, well, hey. So, a couple of tricks on there. The speech synthesis, if you want to do it in headless, then make sure you use the media element and to build that out. Okay, the next part I'm going to talk about is AllJoyn. And I kind of touched on this a moment ago. Is that one of the biggest challenges facing the industry at the moment with Internet of Things and devices is that there's so many of them, and like lots of standards, there's stacks of them, and then none of them interop. And what does it say? Oh, I got to mention. Well, hey, hope that was an okay mention. As a compliment, thank you. And so AllJoyn it's an interesting initiative. It is actually an open source initiative driven by the Linux Foundation. So who would have thought Microsoft would integrate and put AllJoyn into the operating system? And it's actually an open source Linux Foundation platform. You can't imagine that 5 years ago, 10 years ago, it would be unheard of. It's absolutely fascinating to see how Microsoft has changed and really looking at kind of embracing a lot of work that's going on. So we're one of the key members of this AllJoyn, All Seen Alliance. And as I said before, it's a standard way of having devices out there saying, look, I'm a printer, or I'm a camera, or I'm a process control system, I'm a truck, or whatever it is. So, and I'm a truck and I've got an engine, or I'm a process control system, I'm a printer and I've got ink, whatever it might be. For things to be able to broadcast their capabilities and their intents, I guess, in some respects. There's also management capability in there, there's security integration there, and there's interop. So the whole idea behind this is you can have a whole range of these services and applications which are AllJoyn enabled, and they can all interoperate with each other. And that's certainly the vision. And I said, the AllJoyn project is a Linux Foundation, and it was voted, I think, like the most successful open source project. And we have taken that work, and we're a key member of that work, and actually integrated AllJoyn into Windows 10. So be it on the desktop, so you could go and build a tablet-based application, for example, which may go and control a process control system over AllJoyn. You might have bought a lathe from Hitachi, for example, or LG, and you could have that application talking over AllJoyn to that lathe and doing something. So that's fundamentally how these things are going to work. And there are two kind of concepts, and there are two templates that you want badly when you do this stuff, because otherwise it's kind of nigh impossible. Well, it's not impossible, but there's a lot of XML. So you have what's called an AllJoyn producer. So my robot is an AllJoyn producer. Just when I put it into autonomous mode, I actually send an AllJoyn message to it. And you have consumers, and that app that I was running on my desktop was a consumer. I'm consuming that service that thing's producing. And there are two templates. So to create something which produces AllJoyn capability, you want the AllJoyn device systems bridge template. And to go and create an application which consumes it, you want the AllJoyn Studio. And AllJoyn Studio, what it does is you got your AllJoyn application running on your network, and you go into Visual Studio, create an AllJoyn, and you say, listen on the network. And it will find all the AllJoyn devices and say, that's the one I want. It will go and effectively get the XML from that device, put it across, and then croft up all the classes for you. And then it becomes really simple to actually go and build something which talks to AllJoyn. So as I said, it's a fundamental thing that's going on around really trying to address this issue. And just to give you a bit of a sense of what's going on, so the AllJoyn, as I said, at the top you can see it's a Linux Foundation project. And if I scroll all the way down, okay, this is the right page. You can see who are the main members in there. So I said there's people out there building process control systems. There's obviously ourselves, there's Philips, there's people building smart light bulbs, you name it. These folk are in the AllJoyn All Seen Alliance. And then there's a whole stack of them that are participant members. So it's a fairly long list. And it kind of gives you a sense of what's going on in the AllJoyn ecosystem. The other thing about, sorry, just finish it. The other thing about AllJoyn is it's designed to be protocol independent. Now the reality is at the moment, it's really over Wi-Fi, Ethernet, and Ethernet over power. But the protocol has been designed for Bluetooth and Zigbees and a whole range of protocols out there that these things, or these devices will be able to talk over these things. Today we have bridges and things like that to manage that. Go for it. Yeah, I guess it's a similar concept. Yeah, so the question was around universal plug and play. Similar idea, but it's kind of out there in the industry. Yeah. Universal plug and play probably didn't really deal with security and all those types of things. Can't remember. But anyway, this is kind of this is where it's all at. And to give you an idea, so inside Visual Studio, and just so you know with this, when you got these templates in, you go into New and you'll see, voila, there's an OR join app. And let's do it, just so you get a bit of a sense of what's going on. While it's going to take too long. Doesn't matter too much. Now, so with the OR join, so I've already deployed my project onto the robot. So there is this thing called an OR join explorer. An OR join explorer will look out across the network and find out all the devices which are OR join. And you can see over here, there goes my robot, and Glovebox is me, and it's the MakerDen. And you can go and start digging into the interface. Now, this is not the application you'd give to your end users. This is a developer application. And I could see that in here, I'm exposing out some interfaces. Remember, I put the robot into autonomous mode. I've got autonomous and manual. Surprise, surprise, I've got left, right, back, stop, speak, and things like that for the robot. So these are the interfaces that the robot's presenting out. The robot has some properties. You can define the speed, the manual mode, and things like that, etc. And what I did, the way that I built this app was I used that OR join Studio template and pointed it at the robot. And it's probably, Visual Studio has probably come back up now. And you can go and inspect, and this is what's on the network. So it's the same as what you just saw inside Explorer. And there goes the robot there. But see, I'm not going to go into it because by the time, my mouse has died. Okay, now this robot, so what I've done is I've created this application, and you can see now that
Right. Center.
Wahey.
Center. Center.
It was still
Center.
turned on, and it was in.
Center.
So we're going to put this
Center.
into manual mode.
Center. 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 Center.
Whoops. Okay. And you'll see now that I can now control this robot, all my process control system, all my lathe, all my printer, whatever it is. Except now when I want to do the demo. That's funny. Oh. Thank you. And as you can see, I'm basically sending OR join commands across the network. Thank you. I actually cursed the network a bit last time I tried this because I was like, why isn't it working? I hadn't turned the battery on. So that's what OR join is doing for you. And obviously this robot's clearly not the example you're going to deploy in your enterprise. Well, maybe it is. But you get an idea what OR join's about. And it's going everywhere. It's going into a whole range of types of bits of equipment that you may have inside your organization that you want to enable and get at and manage and get the data at and all those types of things and bring them into your systems. Okay. Alrighty, we're on the home stretch. Now, one last little device I want to show. And then that really is it. And I don't have any code for this. Now, what I hear a lot of people say to me is, man, I don't want to get involved in those electronics. And there is this thing, or maybe they're happy to do the electronics, but they don't want to do all the wiring. So there is a thing called Grove Pi. Has anyone heard of this? So Grove is a pretty popular, it's these adapters, you can see they've got a standardized interface, if you can see that on the end of it. And these things, you just plug them in, and this is a display unit here, and I've got a little LED, and I've got a little ultrasound sensor on there, and a relays, and a whole range of things on there. And you can just plug them in. And there are some classes that they're built. You say, I want to go measure the distance. And you just say they've got a class factory. And you say ultrasound sensor. This is the pins that lives and tell me the distance in centimeters. And you're up and running. Whereas the things that I've shown you, they're much more about pulling together wires and stuff like that. But if you want to get up there and build stuff, then GrovePi, and they've just released all the support for Windows 10. Now, not all the sensors are out there for Windows 10 for IoT, but a lot of them are. And again, if you don't want to have to play around and get too grungy with the wiring, then the GrovePi is really awesome. Okay, so kind of just summarizing up here. So getting started. So IoT, the main IoT site, the Microsoft Hackster site is really good. Drivers. So we provide the fundamental drivers inside the operating system, so for I2C and SPI and UARTs and all those types of things. But you need drivers on top of that to go and, for a driver for a temperature sensor, or a driver for a motor, or an ultrasonic sensor. So our MSIoT team, they're building out a stack of drivers. They're just awesome. There's mine are clearly fantastic. And they're okay. And there's another guy out there who's doing some really good sensors. The guy, and he tweets a lot of them. Pori is his GitHub name. And if you just go and say, this is a sensor I want, and just go and search on the internet, you'll find a stack of them. So these are just the ones I've come across of recent, which I thought, oh, those are pretty cool. People ask me, where do I buy stuff, particularly in Australia? eBay is my friend. You can buy stuff ridiculously cheap if you don't mind waiting for like a couple of weeks. You can buy like sensors and all those types of things for a couple of dollars. Strips of LEDs and all those types of things for next to nothing. Amazon's great. Little Bird's based in Australia, New South Wales. Tronics Labs over in Victoria. Core, I think, of Victoria. RS Components, they're worldwide. They have a great selection of things. JCars. That robot kit I got there is from JCars. And I did a bit of extra drilling to get the Raspberry Pi to sit in there. But all pretty much standard places. You can get them either on the web in Australia, or you can rock up to JCars and buy that robot kit that you've been dying to do. What's that, sorry? Element 14. Yeah, Element 14. Thank you, sorry. Yeah, they were on my slides before too. It's funny, I tend to use those more. But lots of suppliers for this stuff. And kind of really just a summary, you kind of got to get a sense of what's going on. So what we're doing around Windows 10 is we'll make sure it kind of participates in your overall management infrastructure, security infrastructure, all those types of things. It's actually certified for Azure out there as well. You build up for Windows Universal, wiring compatible. You can build in pretty much any language you want to go and build in. And it's part of the solution. I don't think it's always going to be the full solution. But as you saw before, I had an Arduino sitting on top of that, or you maybe have other components inside the overall solution. It's the robot. That's cool. And the MakerDen. So make sure you give the MakerDen a go, because it's lots of fun and you'll get a chance to play around. And we're going to be over there and we've got lots of questions. Okay, many thanks. Enjoy the rest of the conference. Yeah, thank you.